ahead and get started. Yes, Cameron, this is going to be recorded, and I will be providing the link to the math department. And so if your instructor wants to share that link with you, they will do so. If you want me to email the link to you directly, then you can put your email in the chat, or you can email me directly if you don't want to put your email in the chat. My email is here. Also, if you just type in Maxine into your Falcon online email, then my name will come up. I know it's confusing. Maxine is my middle name, but that's what I go by. But my email address is brandy.horn. Okay, so this is for the full semester statistics course, so the full 16-week course. So if you're in the 8-week course, you've already had 2 tests and you're getting ready for your 3rd, but you guys are in, hopefully you're in the right review here. So you're taking the full semester course. So this is the first test. And we're going to be going through some of the review questions for chapters, what is it? I think chapters 1 and 2, right? So as I go through, if you have any questions, you can put them in the chat. I'll be looking at the chat throughout, or you can do like a raise hand or something like that. And if you want to, ask the question verbally, we can try and make that happen. But otherwise, you can just type the questions in the chat. Okay, so let's go ahead and get started. All right, number 1, how is a sample related? You guys can already see the answers that are, filled in on these. So we're just going to be going through and talking about, okay, how do we get those answers? Okay, so a sample is a subset of a population, right? So you guys are learning all sorts of new vocabulary in these chapters. So you want to be aware of the population is the whole group. A sample is just a small subset of that. Okay, what's the difference between a parameter and a statistic? So a parameter is a numerical description of a population. So we have population parameters, whereas a statistic is a numerical description of a sample characteristic. So an easy way to remember that is that population starts with P, so does parameter. So you have a population parameter, sample starts with S, so does statistic. So population parameter, sample, statistic. All right, determine whether the data set is a population or a sample and explain your reasoning. The number of floors in 8 buildings in a city. So when they talk about ones like these, when they say in a city, that is going to be your population. They only asked or inspected 8 buildings in the city, right? So 8 buildings is a small subset of the population of the whole city, of all of the buildings in the city. Okay, so maybe in a different problem, city might be the sample because maybe they do something in just one city, and the population in that might be the whole state or something like that. So it just depends on each individual question. So the sample is the smaller subset of the population. So this one's a sample. It's a collection of 8 buildings, the number of floors in 8 buildings in the city. All right. Number 4. A survey of 1,500 US adults found that 58.6% have never had a vaccine reaction. Identify the population and the sample. Describe the sample data set. So when you're going through questions like these, you want to be paying attention to some different phrases and numbers. A lot of times you want to be labeling the numbers depending on what they're asking you to do. So they did a survey of 1,500 US adults, and they found this percentage. So the population in the given problem would be all adults they were only able to survey 1,500. That's our sample, right? The sample is the 1,500. All US adults would be the population, right? So I guess that's just, they're just asking what's the population. So all the responses of all US adults. Identify the sample. That's going to be just the 1,500 that were surveyed. And then describe the sample data set. So you'll notice here that not only have they talked about the number that they gave us, that 58.6% that never had the reaction, they also talked about how many did have a reaction. So a lot of times they're going to want you to not just talk about whatever number they gave, but also, okay, well, what about the rest of the population? So you're going to have to do some math there, right? Because there's 100% of the population and 58.6% never had a reaction. We subtract that. That's how they're getting the 41.4% that did have a reaction. Okay. All right. Okay, identify the data set's level of measurement. All right, so when you're doing these level of measurements, it's a good idea to refer back, and I'm going to pull the book in here, to your table in the book. Here it is. So in the physical book, it's page 12. If you have the electronic book, I'm not sure if it's the same page number, but a lot of times tables like these can be really helpful, so don't skip over them. So this has a pretty clear way for you to understand the difference between the different levels of measurement. So we're kind of starting from the lower and going to the more involved and complicated, and we can do more with it, right? So we have nominal, ordinal, interval, and ratio. Okay, so all of them you can put into categories. Then just the top three, you can arrange them in order. And well, top three, I'm saying, I guess the bottom three, you could arrange in order. And then the bottom two, you can subtract them to get meaningful relationship or meaningful calculations. And then only ratio can you do ratios or multiples to get meaningful calculations. Okay, so let's take a look at that in kind of each of these. So the first one is ages of students in a stats class. So can we arrange in categories? So categories is nominal. Think like nominal, like name, right? The root of nominal, nom, name. So can we name them? Can they be in categories? Yes. Yes, they can. Okay, so definitely nominal. Let's move up to the next category. So can they be arranged in order? So if they're arranged in order, that's ordinal, right? Order, ordinal. And yes, we can arrange ages in order. That makes sense to arrange ages in order. Okay. Can we find meaningful differences? Meaning, like literally subtract them, find the difference between them, which is interval. And yes, we can say somebody is 4 years older than somebody else. And then the last one is, can we find meaningful ratios? Which is ratio. And yes, we can say somebody is twice as old as somebody else, right? So that's the thought process you're going to go through as you do these. You're going to kind of start with the sort of lowest level and work your way up. Okay. All right, so number 6, identify the level of measurement. Okay, temperatures of 18 selected refrigerators. So temperatures generally are going to be at the interval level. They're not going to go up to the ratio level, right? Because it's not just, oh, can I take ratios? It's can I take meaningful ratios? Like, does it actually mean something? Is it useful? So generally, when you see temperatures, that's what's going to tell you that it's interval. Okay. Number 7, a list of social security numbers. All right, so we can arrange them into categories, and we can definitely um, uh, put them into categories, but we can't necessarily put them uh, in an order that would necessarily make sense. Okay, so that's why that's nominal. Okay, so another one, ordinal. So again, we're saying, okay, we can arrange this in categories, and we can put them in order. Like we could say, from poor and then good and excellent, or we could go the other order, right? We could go excellent to good to poor, but they would be in order, so they are ordinal. All right, so determine whether the data are qualitative or quantitative. So qualitative, like quality, versus quantitative, like a quantity, like a number. Okay, that's how you're going to want to think of those. So colors are not numbers. Colors are qualities, so that's qualitative. Okay. The number of seats in a movie theater gives us a hint. It tells us right there, the number of seats in a movie theater. That's quantitative. I'm trying to go fairly quickly through these first ones because a lot of these are just going to be, kind of making sure that you've done your, that you understand the definitions so that we have time to get to the actual calculations. All right, determine if the survey question is biased. If the question is biased, suggest a better wording. Why is drinking soda bad for you? So when you're trying to figure out if something is biased, a good question to ask yourself is the question telling me something? While it's asking me something. So this question told me that drinking soda is bad for me. It's asking me why, but it's also telling me that it is. That's why the question is biased, because it's telling me that it's bad for me and then asking me to explain why, rather than just asking me how it might affect my health, right? So it's assuming something and telling me that versus asking me to tell them if it's bad or how it would affect, positive or negative. Same thing with the next one. How much do you sleep per night during an average month? So is it telling me something? No. I mean, I guess it's telling me that I sleep, but that's not really, oh, got somebody in. All right, so just as a reminder, want to let everybody know that we are recording this. It'll be available via a link afterwards. If you want me to email the link to you directly, either put your email in the chat or email me with your email address asking for it. I'll pop my card back up here so that you can get my email address. Okay, so it didn't ask what things like, oh, how much does drinking caffeine decrease your sleep, or something like that, where it's telling me something is bad and then asking me about why. It's just asking me how much I sleep. It's not biased. So no, it's not biased. Doesn't lead to any particular answer. That's another way to think of it. It does not lead the respondent to any particular answer. Okay. All right, use the given frequency distribution to find a bunch of things. Hold on, let me get this all sorted here. All right, so let's get into some calculations here. So the first thing they want us to find is the class width. So we want to make sure that uh, you don't fall into the trap that a lot of people fall into, which is that they think that the class width goes from here to here. It does not. The class width goes from your lower class limit to your next lower class limit. So let's talk about some terminology here. These numbers here, these are all lower class limits. These numbers here are upper class limits. Okay, so your class width is how much you have to go to get from one lower class limit to the next lower class limit, or from one upper class limit to the next upper class limit. So what did I have to add to 135 to get to 140? I had to add 5. So that's going to be my class width, is 5. Okay, then it wants the midpoint of the first class. So the midpoint of a class, any class, is the average of the lower class limit and the upper class limit. So it's asking specifically for the midpoint of the first class. So let's do that one. So how do we take the average of these? We add them up and we divide by 2. Okay, now a quick note here, when you're plugging this into the calculator, make sure that you do not plug in this. That is wrong. Order of operations will have the calculator doing this first as opposed to these together. So if you're going to plug this into the calculator, there's 2 ways you can do it. You can do a parenthesis around the numerator, or you can just say 135 plus 139, get your answer, and then do that answer divided by 2. Okay, so that's going to look like either 135 plus 139, whoops, well, there we go, and then divide by 2. Okay, or if you did want to put it in all at once, 135 plus 139, close parentheses, divide by 2. So just be careful. You don't want to accidentally get a question wrong because you just typed it into the calculator wrong. Okay, so that was 137. So whenever you're doing any of these problems, really any problem in stats or any math class, once you get your answer, you want to pause for a second and you want to say, does my answer make sense? Is this a reasonable answer given what I have going on? So we were trying to find the midpoint of the first class. So the midpoint is going to be the number that's halfway between these two numbers. So does it make sense that 137 is halfway between 135 and 139? Yeah, that makes sense. So let's say that, because I don't know if you guys noticed, but when I first typed this in, I didn't type in 135. I missed the 1 and I just typed in 35. So let's say that I didn't catch that. And I did that. And I said, oh, my answer is 87. When I stopped to say, well, does that make sense? I would have said, oh, wait, no, that doesn't make any sense. 87 is not halfway between 135 and 139. And I would have caught my mistake before getting a wrong answer. All right, so the next thing it wants are the class boundaries of the first class. So a lot of people get confused with limits and boundaries because I know they sound very similar. But remember, your lower class limits and your upper class limits are right here in your class. The boundaries are the numbers that are halfway between here and here. Okay, so we say, you'll notice here, this class ends with no overlap to this class, right? If I have a number and I'm trying to figure out which class it goes into, there's never going to be any question as to which class it is in terms of, you know, oh, it could be in that class or in that class. It's only ever going to be in one of these classes because there's no overlap, right? Like for example, I don't have like, 135 to 139 and then 139 to some other number. Because then if I had the number 139, I would say, okay, well, does it go in this class or does it go in this class, right? That's why we don't have overlap there, so that there's no question as to which class it goes in. So the boundaries between the classes are, okay, well, what's halfway between here and here? Because there is a gap, right? There's a gap of 1 between here and here. So we need to find that gap. So it's between here and here. It's between here and here. And they want it just of the first class. So we're going to start by finding the gap between the first class and the second class. And we do that by getting the average of these two numbers, very similar to what we did over here, right? So I'm going to do 139 plus 140 divided by 2. Now, if you can kind of do it in your head and say, well, what's halfway between 139 and 140? Then go for it. It's going to be 139.5. But if you don't feel comfortable doing that in your head, saying what's the decimal that's halfway in between those, then just go ahead and plug it into the calculator. Okay, so the reason that we did this one first is because, so first of all, I'm just going to go ahead and write 139.5 right there. The reason that I wanted to do that one first is because that makes it a little bit easier for me to figure out what the lower class boundary is. So that's our upper class boundary. Our lower class boundary, well, we have no class before it to compare it to. So how would we know how far to go? By figuring this one out first. So what we're going to do is we're going to look at the upper class limit and the upper class boundary and say, well, how far away are they from each other? This is 0.5 away from that. So my lower class boundary needs to be that same distance away from here. So this needs to be 0.5 away from there. So I'm going to do 135 minus 0.5. And that's how I'm going to get the 134.5 as my lower class boundary, my upper class boundary. Okay. All right. And that's all I wanted from this one. Okay. Okay, so what are some benefits of representing data sets using frequency distributions? What are some benefits using graphs of frequency distributions? So again, just kind of checking that you guys are understanding, why do we use these? Because we can see the patterns. Makes it easier to see the patterns. And then when we graph them, it's easier to see the patterns, right? It's easier to identify the patterns and figure out what's going on if we display them in these ways, rather than just having a raw set of data, which is just a list of numbers, right? Okay, determine whether the statement is true or false. If it's false, rewrite it as a true statement. The difference between two consecutive midpoints is equal to the class width. So that is true. So real quick, I'm going to go back actually to the problem we were talking about, midpoint, or yeah. So I'm going to go back real quick to this one. So when we were talking about the class width, and I was saying the class width is what you have to add to the lower class limit to get to the next lower class limit, right? The +5, and then you can add it again, and then add it again. Same thing over here, I can add it again, add it again. That's also true for the midpoint. To get from one midpoint to the next midpoint, you just add your class width. Okay, so if we were to like add a column for midpoint, they didn't ask us to do this here, but all right, so we calculated the midpoint of the first class was 137. Instead of going through and doing that same calculation for each of these where we add them together and divide by 2, add them together and divide by 2, we can just add 5 to the midpoint to get the next one, and then add 5, and then add 5, and then add 5. right? So that's why it's really useful to find the class width. Okay, so that is why the statement is true. The midpoint is the sum of the lower and upper limits of the class, then divided by 2, right? That's how we get averages, add them up, divide by how many there are. The distance between the two consecutive lower or upper class limits is equal to the class width, as is the difference between the consecutive midpoints. All right, use the given frequency distribution to find, again, several things: the width, the midpoints, and the boundaries. Okay, so the width. What do I have to add to this to get to here? A 3. Right? You can just do that in your head, or you can plug it into the calculator. You can say, what's 43 minus 40? I guess we could probably do it like that. There we go. Okay, so the class width is 3. The midpoints, they want you to find the midpoints for every single one of these. So you're going to start by finding the midpoint of whichever class you want. I'm going to start with the first one. And once I find that midpoint, I'm just going to use the class width to find the next midpoint down. So class width, that was 3. The midpoint, I'm going to do the lower class boundary. I'm sorry, the lower class limit plus the upper class limit of this class and divide by 2. And that's going to get me 41. So that's how they got the 41 down here. And then again, I could add them up, divide by 2, add them up, divide by 2, and so on and so forth. Or I could just say, well, what's 41 plus the class width? Right, 41 plus 3, plus 3, plus 3, so on and so forth. And that's how we're getting all of these midpoints. Again, you want to stop and check. Do my numbers make sense? Are these numbers that look like they could be the midpoints? Right, and then the class boundaries. So again, we're doing the same thing we did before, where we say, okay, the boundary, you know what, maybe I'm going to do between here and here. So I'm going to say, what's the class boundary between 51 and 52? So again, I'm going to add them up and divide by 2. Or if you can kind of say in your head, well, what's halfway between 51 and 52 is going to be 51.5, which means that over here is 51.5. So what do you think I'm going to add to this to get to the next one? The class width, right? And then so on and so forth. So that's kind of move this up a little bit here. I'm not going to go through and do every single one, but excuse me, that's how they're getting all of these numbers here. Okay. So the number over here is going to be 0.5 to the left of that. So 39.5. And then, oops, sorry. And then the boundary over here is going to be 0.5 more than that. So 60.5, because that's how far that is from that. Okay. Okay. Use the frequency distribution shown below to construct an expanded frequency distribution. All right, so they've given us the classes and the frequencies, and they want us to find a bunch of things, right? So they want us to find the midpoint, the relative frequency, and the cumulative frequency. So the midpoint, we know how to do this, right? We've done it several times now. We do, I guess I'll do it over here. The lower class limit plus the upper class limit divided by 2. Again, or you could just do it in your head, or you could plug it into the calculator. And once I find that, I can just add my class width. So let's go ahead and identify, what is the class width? How did I get from, from 20 to 31? I had to add 11. So that means I'm going to add 11, Add 11, you get the idea, so on and so forth. All right, so that's how we do the midpoint. Okay, so let's talk about relative frequency. So they gave us the frequency. Now they want the relative frequency. So what we have to do is we have to find the sum of the frequencies. Okay, so this symbol is the capital sigma. It means sum. I didn't draw it very well, but hopefully you guys can see what that's supposed to be. So it means the sum of all of the frequencies. So we're going to add these up. So sometimes they'll tell you, like if they're describing, oh, these are high temperatures, they might give you a little paragraph about it, and they might tell you, how many temperatures were taken. So sometimes you don't have to actually add all these up. They might give that to you, but in this case, we do need to add these up. So it's 44, 68, 57, 68, 22. Okay, so that's 365. So relative frequency is the representation of the frequency of this particular class in relation to all of, the data points. So what you're going to do is you're going to take the frequency that you have. Actually, I guess I'll write it up here. Can I zoom in a little bit? I feel like I'm writing really small. This has a frequency of 17. So we're going to do the part over the whole. We're going to do 17 over 365. And we're getting this decimal. They told us to round to the nearest hundredth as necessary. So quick reminder on rounding, 5, 3, 4, 2, 5. This is the tenths. This is the hundredths place. If we're rounding to the hundredths, we need to look to the number to the right of it. If this number is 5 or more, this number goes up 1. If this number is 4 or less, this number stays the same. So since this is 5 or more, this number goes up to 0.05. Excuse me a moment. Sorry, getting a bit of a dry throat here. All right, so that's how we're getting the 0.05 is we took the frequency of the class and divided it by the sum of the frequency, right? We did the frequency of the class divided by the sum, the sum of the frequencies. And that's what we're going to do for each of these, right? 44 over 365, 365. Rounded to 2 decimals is 0.12, so on and so forth. You get the idea. All right, cumulative frequency. So cumulative frequency wants you to take the frequency that you have and add to it everything above it, all the frequencies above it. So for the first one, it's just 17. There's nothing above it. But for the next one, they want you to take 44 and add it to 17. So you're saying this class and all the classes above it. So that's going to give us 61. All right, for the next one, we're going to do this class and all of the classes above it. So we're going to take that number that we just had and we're going to add 68 to it. That's how we're getting 129. So on and so forth. This class plus all the classes above it. So we can just hit plus to get the next number, 198. So on and so forth. Okay. And yeah, that's all they wanted for this one. Okay. A misleading graph is a statistical graph that is not drawn appropriately. This type of graph can misrepresent data and lead to false conclusions. Understanding how data can be manipulated or presented in misleading ways is a really important skill as a citizen. So what we have over here is called a Pareto chart. And one thing I want to note here is that in a Pareto chart, you're supposed to arrange the columns so that they are in decreasing height. from left to right. That is a feature of a Pareto chart. It's something that you have to do. Excuse me. So I bring that up because people might look at this and say, "Oh, well, they've rearranged the quarters, so that must be what's misleading about it." But that's what you're supposed to do in a Pareto chart. In a Pareto chart, they want to draw your attention to the largest thing first and say, "Hey, that's what this one is," and then you go in order from there. So what is misleading about this one? Well, if we take a look at the y-axis, right? This is the x-axis, this is the y-axis. You'll notice that it starts at 90 and then goes to 130. It doesn't start at 0, and it doesn't show that there's been any sort of break. So sometimes you might see that in a graph where you have like a squiggly line like that, and that shows that, hey, on the x-axis, this is 0 and this is whatever, but on the y-axis, we did a break before we show the rest of it. So they're not showing that. They're just starting right off the bat at 90. So that's what's misleading about it, is that there is a large gap in the vertical axis. It makes it appear that the sales for the third quarter are disproportionately larger than the others. Okay, so what are they talking about? Well, what if we drew it the correct way? Okay, this is what it would look like. So when you look at this, you say, wow, this is so small compared to that. This is, this is multiple times as big as that. But when you look at them here, when you're comparing, kind of apples to apples, you can see, well, this is not that much different than that. I mean, yeah, it's lower. Absolutely, it's lower. But this is not multiple times bigger than that. Whereas if you're just glancing at this, that's what you're going to think, right? Okay. Right, the top 14 speeds in miles per hour for professional drag racing over the past 2 decades are listed below. Find the median speed. Okay. Sorry, taking a drink break again. All right, so median. Mean means your average. Median is the number in the middle. So you can keep those two straight by remembering median, like the median in the road. It's the thing that goes in the middle of the road. Okay. So when you have, you're either going to have an odd number of terms, number of numbers, or you're going to have an even number. Okay. So the way that you find the median speed, or well, in this case, speed, if you have an odd number, and I'm going to use my hand as an example. So if I have 5 fingers and if I have 5 fingers, I have 5 fingers, and I want to know the median, what's the one in the middle, that's going to be this one right here, right? My middle finger, literally middle finger. Okay. So mathematically, how could I have gotten to that? Well, if I take 5 and I cut it in half, well, that's going to give me 2.5. So cutting it in half actually puts me here, 2.5. So what I need to do is I need to go up to the next whole number. So if you have an odd number of numbers, you're going to divide by 2, then go up to the next whole number. And we'll do an example in just a minute here. If you have an even number of terms, so let's say I have 4 terms, I have 4 fingers. Well, what is the median of these? Well, it's going to be right in between the second and the third fingers. Okay. So how could I get there? If I took 4 and I divided it by 2, well, that would get me 2. So what I need to do is I need to take the average of that and the one above it. Okay. So for even, I didn't mean to write that there. You're going to divide by 2, then take the average of that number and the one above it. So if you ever get confused as to which process you're supposed to use, just go back to your fingers. Just say, well, what would I do if I had 5 fingers versus 4 fingers? Okay, and that'll tell you what process to use. So let's say I had, 15 terms. Okay, that's an odd number. I need to say, well, which term is going to be the median? This is an odd number, so I'm going to divide by 2. So I'm going to say 15 divided by 2 is 7.5. And then I'm going to go up to the next whole number. So I'm going to go to the 8th term or the 8th item when they're in order, right? That's that's first step, right? Is to put these in order, which we'll do in a minute. So once they're in order, if I go to the 8th term, that's going to be my median. Whereas if I have 14 terms, if I have an even number of terms, I'm going to divide by 2. Okay, so that's 7. And then I need to take the average of that number and the one above it. So I'm going to average the 7th and 8th terms. Right, that's how we're going to do that. So once we know which term we have to use, we need to make sure that they're actually in order. So there's a few ways to do that. You could certainly just rewrite it, right, depending on how many numbers you have. So we have 14 terms here. We could rewrite them, or we could let the calculator do it. Okay, so let me show you how to make the calculator do it. So first thing you're going to do is you're going to go to your stat menu. So that's right here, stat. Okay. And we want to edit this list. So once you're highlighted on edit, you're going to hit enter. So if you have things in here already and you want to clear them, you're going to go up to you're going to highlight the top where it says L1, and you're going to hit clear and then enter. And that's how you can clear the whole list right away. And then I'm going to arrow over, arrow up, clear and enter. All right, so I'm going to enter all of these data points into the calculator, and then I'm going to have the calculator sort them. Okay, so if you have a calculator and you want to go ahead and do this with me, okay, so I've put all the numbers in. So now what I'm going to do is I'm going to tell the calculator to sort it. So I'm going to go back to stat, right, that stat button. But this time you'll notice under edit, I have sort A and sort D. That's sort ascending and sort descending. We want to sort ascending, so the smaller numbers are at the top and then they get bigger as they go. So we're going to arrow down to there and hit enter. And it says sort A, and then it has an open parenthesis. We have to tell it what we want it to sort. Well, we want it to sort list 1, right? Because we put our data in list 1. So down at the bottom of your calculator, you'll notice that down here above the 1, it says L1. So just like on a computer, how you might use like a shift button, that's what second is for. Second does the thing to the top left, right? So I need to tell it to do list 1, so I'm going to do second, and then the number 1, because that puts in L1. And then I like to close my parentheses. It's not required in this particular case, but it's always a good idea to close your parentheses and then hit enter, and the calculator says all done. And we say, great, thank you. And then we go and look at what it did. So where do we look at what it did? Back where we put the data in. We go back to stat and we go back to edit, right? That's where we put the data in. And now the data is in order, okay? So now we can go through and we can say, okay, conveniently, I picked a number that that was actually the number that we had here, right? Our N, our sample size here was 14. We had 14 numbers. So if I have 14 numbers, I need to average the 7th and the 8th terms. So I'm going to go down and I'm going to say, okay, I have the 7th and the 8th terms. I need to average them. So I'm going to add them together and divide by 2. To get out of here, I'm going to quit, right? So that second mode will quit, second mode. And I'm back to the sort of home page. You can kind of think of it like that, right? So I'm going to do 196 plus 196.2 divided by 2, and I get 196.1. All right, so not too bad, but that was the long way. Let's have it do it the easy way. So we're going to go to stat. So let's pretend like we're doing this fresh. We're going to go to stat. We're going to edit. We're going to type in all these numbers. They don't have to be in order. Then we're going to go back to stat and we're going to have it calculate something for us. So I'm going to arrow to the right to calculate. We are going to calculate one var stats, right? One variable statistics. Now, your screen might look a little bit different than mine. If your screen doesn't have this option here of frequency list, that's what FREQ is short for, frequency list, then you're just going to put in L1. But if it does prompt you for this, make sure that you clear that. You're going to arrow down and then you're going to hit clear, because all we had was a raw set of numbers that went in list 1, and we're not doing anything else. Just the numbers are in list 1. That's all we want it to look at. We don't want it to look at another column. All right, and now we're going to have it calculate, and it's going to spit out a ton of numbers, one of which is going to be the median, right? So something that you're going to learn is that, or hopefully you've already learned, is that the median is also the second quartile. So that's why it's down here in between the first and the third quartiles, because the median is the second quartile. So if they ever ask for the second quartile, it's just the median. But it does label it as median for you. So that's how we're getting 196.1. So again, we could do it the long way. If you're taking a test and you have to show your work by hand, right, you're doing this. But if they don't need you to do that, which a lot of professors are fine with you just learning how to do it in the calculator, then that's what you'll do. So again, we go to stat, we edit, we plug all our numbers in. We don't even need to have the calculator sort them. We go back to stat, we tell it to calculate. We go to one var stats. We make sure that list is L1. If it's not L1, go ahead and make it L1. And then we tell it to calculate. This is a good opportunity to remind you guys that every professor is going to do things a little bit differently. So if I'm doing something that is not the way that your professor has said that they want you to do it, then go ahead and do it the way that your professor wants you to do it. If the way that I'm doing it is so different that it's kind of confusing, then let me know and I can go through it whatever other way your professor wants you to do it. Okay. But yeah, make sure you're always following whatever their preference is. Okay, moving on, number 20. Determine whether the approximate shape of the distribution in the histogram is symmetric, uniform, skewed left, skewed right, or none of these. Okay, so let's talk about the different types of skewing that we can have. So when we talk about left skewed, the tail is to the left. Okay, some people get confused because they're like, oh, well, the taller portion is on the right. It's about the tail. So where's the tail? The tail is on the left. You can kind of think of it like an arrow, like it's pointing to the left. Versus if you have something that looks more like that, that is skewed right because it's pointing to the right. Okay. Uniform means that they are all the same. Uniform is also symmetric, but you can have uniform. You can have lots of different types of symmetric histograms. So symmetric things can look like that. Symmetric means that if you were to cut it down the center, the two sides are mirror images of each other. Okay. So something like that would be symmetric. If you had something like that, You could cut it down the middle. That would also be symmetric. Or you could have something like that. That would be symmetric. Right? So there's lots of different ways to be symmetric. Uniform means they are all the same. Skewed left is your tail points to the left. Skewed right is your tail points to the right. Okay, so what is this one doing? Well, if I were to kind of like round this off, what would this look like? It would look kind of like that, right? It would look like it was skewed to the left. It's got a tail pointing to the left. Okay. All right. Okay. Approximate the mean of the grouped data round to the nearest whole number. Okay, so let's talk about a few things. So it's telling us to approximate. Well, why do we have to approximate? Why can't we just find the actual mean? Well, because you'll notice that we do not have a raw set of data. This is not just a list of 14 numbers or 50 numbers or something. It's already been put into this frequency distribution, right? So we don't know what the original numbers were. We don't know the original data set. So this is telling us that we had 9 different data points that fell into this category, but we don't know where they fell into the category. For all we know, all 9 of them were 135, or maybe all 9 of them were 139, or maybe they were sort of evenly distributed throughout the class. We don't know, which is why we are approximating. Okay, so how do we approximate? What we have to do is we have to find the midpoint. I'm going to move this over. The midpoint of each class, and we have to assume that that midpoint is what occurred 9 times, or that midpoint is what occurred 7 times, or 20 times, or so on and so forth. And we're going to do our calculations assuming that the midpoint is what occurred in each of these, since we don't know what the original data looked like. Okay. All right, so how are we going to do that? So remember, the midpoint is you take the average of the lower class limit and the upper class limit. So I have a lower class limit of 135, and I have an upper class limit of 139. So I add those together and divide by 2. I'm going to get 137. Okay, great. That's the midpoint of my first class there. So again, as we did with several other problems, I can either add these together and divide by 2 to get my new midpoint, or if I just find my class width real quick, I can just add that to every midpoint. So let's do that. Let's find the class width. What did I have to add to 135 to get to 40? I had to add 5. So that's what I'm going to add, excuse me, to every midpoint to get the next midpoint. So in the calculator, I have 137, and I'm going to do plus 5. And then I'm going to do plus 5. And then I'm going to do plus 5. And then if you do the same function in your calculator enough times, the calculator's like, okay, I get the pattern. And you can just, instead of hitting plus 5, you can just hit enter, and it'll say, oh, did you want to add 5 again? And it'll continue that pattern for you. So if you have a bunch to do, you can do it that way. Just a neat little trick. Okay, so we've created our midpoints. We have our midpoints and we have our frequencies. These are the 2 things that we're going to be putting into the calculator, okay? Your list 1 is your midpoint. Your list 2 is the corresponding frequency of that class, of that midpoint, okay? So you're going to go into stat. You're going to edit, right? Stat, edit. Again, to clear this, I'm going to arrow up to the column header, hit clear, and then hit enter, and it clears it. Just a moment. Also, we are definitely going to be running over on time here. So I do apologize. I'll keep going until I've finished all the questions. If you can't stay till the end, that's fine. we've all got school and jobs and all sorts of other obligations. So you're not required to stay until we're done. Like I said, I will be emailing you guys this recording so you can watch it later at a more convenient time for you. Just remember to provide me your email address, either in the chat, or if you don't want to provide your email address in the chat, then you can email me directly, and I will send you the link. Also, I will be providing the link to the math department, and if your professor chooses to provide you with the link, they will do so. Okay, so so we're going to put all these numbers in. Remember, L1 is our midpoint. Okay, 137, enter. 142, enter. Right, that's how we get from one to the next, enter. Okay, and then L2 is our frequency. Also, I didn't talk about it, but we're checking as we go to make sure that the midpoint makes sense. Yeah, 142 sounds like it would be between 140 and 144, right? You're just checking that each step of the way. Okay, so we put in our midpoint of L1 and our frequency of L2. Okay, so now we're going to have the calculator calculate things. We're going to go to Stat, and then we are going to arrow over to Calc. And we're going to do the very first one is one var stats. Okay, so this time we do need to tell it to look in both list 1 and list 2. So again, in my calculator, it prompts me, hey, do you have a frequency list? And I say, well, yes, I do. And I tell it to look at list 2. So again, just gonna, L2 is down here above the number 2. So I'm going to say second 2 to tell it L2. Now, if your calculator doesn't prompt you for this, then it might look like it'll say like one var stats, and then it might have like a parenthesis. You have to put in L1 and then a comma and then L2 and then close your parenthesis. Okay. All right, and then calculate. Okay, so it's provided us with a whole bunch of numbers. And what were we trying to find? The mean of the grouped data. So the mean, or X bar, right? That is the sample, the symbol for sample mean. And we'll go over all the symbols. I think there's another problem where it comes up again, what the different symbols are for mean versus population. But X with a bar over it, we pronounce that X bar, or mean is, so in the calculator, it's 147.952381, but they wanted us to round to the nearest whole number. So the good thing about multiple choice questions is if you forget to read the question, the answers might prompt you to remember that you were given more directions. So if you don't have a multiple choice question, if you have a fill in the blank, or if you're taking the test, with paper and pencil, just be extra careful that you're fully reading the question, and that you are doing whatever rounding is requested of you. Again, you don't want to get a question wrong just because you didn't put the answer in the right format, right? If you did all this work and then you forgot to round it appropriately, you wouldn't want to get points off for that. So just be careful of that. Okay. Determine whether the following statement is true or false. If it's false, rewrite it as true. The mean is the measure of central tendency most likely to be affected by an outlier. So that is true. And in the next couple questions, or I think the next question, it's kind of proving that to us, where we are going to change a number and we're going to see that the mean is affected most. And it's affected most by any change, not just an outlier. So remember, an outlier is that data point that maybe either doesn't make a whole lot of sense or is not usual for your data. Okay, determine whether the approximate shape of the distribution is symmetric, uniform, so on and so forth. Okay, so we had already talked about these, right? We had talked about the shape that looks like, go through so much lead. The shape that looks generally like that has the arrow right? Arrow pointing to the right. That's kind of what this is looking like, right? Skewed to the right because we have a tail on the right. Okay. Oh, I'm sorry. So would a question like this also be multiple choice on the test, or would it be type your own answer? So I'm not sure. So several of these questions are not just multiple choice, right? There are definitely parts where you do need to type your answer in. Um, I don't know that they're trying to trick you when they ask you to round. Um, so I would just say, just double check whenever you're doing a fill in the blank answer. Just double check what you're supposed to be rounding to. But yeah, you're probably going to have a mix of fill in the blank and multiple choice. So, okay, we're getting there. We're almost done, guys. All right. The number of credits being taken by a sample of 13 full-time college students are listed below. Find a bunch of things: mean, median, mode. And yeah, okay. So we're going to do this in our handy dandy calculator, right? So we're going to go to stat. We're going to go to edit. I'm going to clear this first list. Now I'm not going to worry about the second list because I'm not going to be using it and I'm not going to tell the calculator to calculate anything with it. But if I were dealing with like classes and their corresponding frequencies, then yes, I would need to clear that to put new things in it. Okay, so I'm going to enter these numbers. These numbers are not in order. They have not been sorted. 1, 2, 3, and 10. Okay. So I'm now going to tell the calculator to do a bunch of stuff. So we go stat, we go calc, one var stats. I'm going to remove frequency. So I'm going to arrow down and I'm going to clear where it's telling me, oh, do you have a frequency list? And I'm saying, no, I don't. I just have numbers. Please just look at list 1, L1, and calculate. Okay, so they want the mean. So that is the X bar. Oh, by the way, 13, that's our N, right? It can be helpful to number these, or I mean to label these. I mean, not necessarily this in this particular problem, but it's good to get in the habit of when you're reading a question, try and label what they're giving you. Okay, mean is the X bar. So the mean is 8.2. Let's see, here we go. Yeah, rounded to 1 decimal place. So that's how we get 8.2. Then they want you to say, does the mean represent the center of the data? Yeah. Yeah, that sounds about right. If you wanted to, you could go and you could say stat sort list 1. Oops, didn't mean to hit it again. And you could say, okay, well, if I put them in order, the center of the data, yeah, 8's around there. It sounds about right. So yeah, the mean represents the center. Okay, and we have more things it wants us to do. Okay, the median. So again, going back to our calculator, the median, we have to arrow down, the median is 8. So 8, pretty similar to mean, right? Those are both numbers that represent the center, right? Those are pretty near to the center. Then it wants the mode. So remember, mode is the number that occurs the most number of times. So the mode can be easy to find if you have sorted your data. Excuse me. So it can be a little bit easier to count. So like for instance, if we go back and look at the original data set, you know, I might think that I only have 2 8s, but when in reality I have 3 8s. They're just not all grouped together. So we have 6 of these. Really, I guess I should circle them individually. So I have quantity 6 of the number 7. And I mean, we do have 3 8s, but when you have a mode, you either have one mode because it is the most number of times, so the mode would be 7, or you can also be bimodal. You can have 2 modes. So let's say I had a bunch of 10s. I had a total of 6 10s. Well, if they're both occurring the same number of times, if they're both occurring 6 times, then they are both the mode. So you would have modes of 7 and 10 if 10 were also occurring 6 times. Okay, so that's why the mode is 7. But then it also asks us, does the mode represent the center of the data? Well, 7 is literally the lowest number that we have in this list. I mean, we've got a lot of them, but it's the lowest in the list. So no, it doesn't represent the center because it is the smallest data value that we have. Okay. And then do they want us more? Okay, no, new question. All right. The gas mileages in miles per gallon for 30 cars are shown in the frequency distribution. Approximate the mean of the frequency distribution. So we did one like this before, right, where we found the midpoint. Right? And again, we are approximating because we don't have the raw data. We don't have the actual numbers. So we're going to have to assume that the midpoint is what occurred 12 times, and the midpoint is what occurred 11 times, and the midpoint is what occurred 4 times. So again, and I'm just going to kind of fly through this because we've already done one and we're over on time, and I want to make sure to get to the other types of problems. So to find the midpoint, I'm going to take the average of these. So I'm going to add them together and divide by 2. That's going to get me 32.5. I'm going to add my class width to get the other midpoints. So to get from 30 to 36, the class width is 3. So again, to leave that window, you go second quit. I'm going to go 32.5. I'm going to add 6 to get 38.5, add 6 to get 44.5, and add 6 to get 50.5. And then I'm going to double check, do my answers make sense, that those would be the midpoints. Yes, that makes sense. So then I'm going to go into my calculator and I'm going to say that list 1, I'm going to put in all the midpoints. That's going to be what I put into list 1. And into list 2, I'm going to put in my frequencies. Okay. So list 1 is your midpoints, list 2 is your frequencies, and then you're going to do, I'm not actually going to plug it in just for the purposes of time, but we would go stat, we would go edit, we would plug in the midpoints into list 1, we would plug in the frequencies into list 2, then we would go stat, arrow over to calc, 1var stats, and we would have to tell it, yes, please take a look at my frequency, which is in list 2. And then we would have it calculate. I'm not going to actually have it calculate because I haven't actually plugged these in. But that's what we would do. Well, okay, I am going to hit calculate. That's not these. No, yeah, I didn't put numbers in, so it's like you have an issue there. But remember, the mean is the X bar, right? Okay, just one second. Okay, so now we have a slightly different thing here. The number of hospital beds in a sample of 20 hospitals is shown below. Construct a frequency distribution and a frequency histogram for the data set using 5 classes. Describe the shape of the histogram. All right, so if you're taking this test by hand, they may not give you this, right? They may not give you what the classes are. You might need to come up with the classes, okay? So in order to do that, the smallest number, so you might go through here and you might plug all of these into stat edit. You might plug all of these numbers into list 1, and then you might have it sort. So you would go stat, arrow down to sort, and then you would tell it to sort list 1. And then you would go back and you would look at that. And you would say, okay, what is my lowest number? What is my minimum value? That's going to be your starting number for your class. Then you have to determine what your class width is going to be. So to determine your class width, you need a couple of things. You need to know your range, and you need to know the number of classes that you want, okay? So to find our class width, we're going to start by taking our range, which we'll talk about in just a second, and divide it by the number of classes that we want to create. Again, this is the process that you would use if you were not provided this and you had to create this part on your own. So the range. So what is the range? The range is the maximum value minus the minimum value, right? And then I'm not going to rewrite number of classes. Okay, so what is our maximum value? If we were to put this into the calculator and then sort it, we could easily tell, or depending on how big of a data set you have, sometimes you can just look at it and tell, okay? So our maximum value here is 287. That's our max, okay? Our minimum value is 127, okay? The number of classes, well, they told us how many classes to create. They told us that they wanted us to create 5 classes, okay? So real quick note, generally you want to have between 5 and, oh shoot, is it 15 or 20 classes? You don't want fewer than 5, and you don't want a ton, because then it's just kind of hard to see the patterns, okay? So I'm going to rewrite this. So actually, I'm going to do this down here. This is going to give me 32, but when we're finding the class width, we have to take this and then go up one more. Go up one more number. So you do the range divided by the number of classes, and then you go up one more, right, to 33. That's a 3. My 3s look funny sometimes. You have to go up one more. If you just leave it as this number, you're not going to have enough. You're going to fall a little short. So you have to go up to the next number. Whether this is a decimal or not, you got to go up. Okay, so don't forget that. Okay, so that is our class width. So we add our class width to get to the next lower class limit, and so on and so forth. Now, when you're creating this, again, we're pretending like we don't have this. We say, okay, well, my minimum value is 127. And this is going to be, where the frequencies are. Minimum value is 127. I'm not going to fill in my upper class limit for this class just yet. I'm going to start by adding my class width to get my next lower class limit, because then it's a little easier for me to see, okay, if this is 160, what's this? Well, it's got to be 159, doesn't it? And then I can keep going from there. I can add the 33 over here, and I can add the 33 over here, okay? Then you're going to create your, I did not leave myself enough room here. You're going to create your tallies to help you create the frequency. So I would go, okay, 168. So let's pretend like these aren't here yet. Well, that is in this group. So I'd put a tally mark. Okay, 160 also here. 127, that's here. 127, 182, 163, 168. And you would continue creating your tallies until you've gone through all of the numbers and said which class they're in. Once you've done all your tallies, then you can say, okay, I mean, in this case, it would look like that. And we would say, okay, I did 6 tally marks, so I would do 6. So that's how you would create that from scratch. Okay, so we've created the frequency distribution. Okay, now it wants us to create a frequency histogram. Okay, so there's several different ways that you can label them. If this is multiple choice, it's a lot less work, right? Because what you can do is you can go through and say, okay, I need the frequencies to be 6, 6, 4, 2, and 2. So we say, oh, well, the frequency on this first one is 2. Well, that's not right. It's supposed to be 6. Okay, so that one's out. Okay, the frequency on this one is 6, but the next one is also supposed to be 6. Okay, that's out. And we say this one, okay, I've got a frequency of 6. So remember, frequency, that's here on the y-axis. Frequency of 6, frequency of 6, frequency of 4, frequency of 2, frequency of 2. Okay. If you have two that look the same in terms of, what their frequencies are, double check the numbers on the bottom. So the number in the middle here is your midpoint. Okay, so they haven't labeled these, but if you wanted to, you guys can't see that. It's not focusing. Anyway, the number in the middle of this rectangle is the midpoint. So if they were to label that, that's what would go there. Okay. This number right here is your lower class boundary. This number right here is your upper class boundary for your first class, as well as the lower class boundary for the second class. So remember back when we talked about boundaries, we were saying that it's the same number, right? The here, let's go back up to here. If I were to find the boundaries here, the boundary here is going to be the same number as here, right? It's going to be 159.5. That number goes here and it goes here when I'm finding my boundaries. That's why these share a line, right? The right side of this rectangle is the exact same number as the left side of this rectangle. So that number that they share is the boundary. So I don't know that you guys are going to have to create them yourselves, but just be aware that that might be the way that you want to do it. Okay, so this is the graph, and we're going to say, okay, what does this look like? If I had to draw it, it would look something like that. So that is skewed to the right because the tail is on the right. Okay. Okay, we're getting there. Okay, during a quality assurance check, the actual contents in grams of 6 containers of protein powder were recorded as, and it gives a bunch of numbers. Find the mean and the median. Then we have a value was incorrectly measured. We need to recalculate, and then which was more affected by that entry error. Okay, so we're going to go in, we're going to go stat, we're going to edit. I'm going to clear this list. I'm going to plug in these numbers, 1528, 1526. Okay, and I want the mean and the median. So I'm going to stat calc var stats. I'm going to tell it, no, please don't look at list 2. I didn't put anything in there. I'm just looking at list 1. So make sure that if your calculator looks like mine, make sure that you're doing that every time. Okay, or that you're checking, do we need it to look at list 2? And if you find that you're not sure, then just clear list 2. Like if you're not supposed to have numbers in there, then just get rid of it. Okay, so we want the mean, right? So we have 1519.5, that's this X bar. The median, again, we have to arrow down for the median. That's 1521, okay? Then for part B, the third value was incorrectly measured and is actually 1518. Okay, 1, 2, 3. So instead of that, we actually have 1518. So let's go back in and change that. We're going to go stat, edit. The third value is now 1518. Stat calc. And this time, the mean is 1522. And the median, again, we arrow down, is also 1522. Okay. All right. So the mean went from here to here. The median went from here to here. So after correcting the error, what did the mean do? From here to here, it increased by 2.5, and the median also increased, but only by 1. Right? Do you see that? From here to here is the mean, from here to here is the median. So the mean increased by more than what the median increased by, which I think is what it asked next. Oh, I must be missing that part of the question, but oh no, it's right here. The mean was affected more because it was increased by more when that data value changed. Okay. All right. The heights in inches of 20 adult males are listed below. Find the range of the data set. So I think I said this before, sometimes it's going to be faster to plug it into the calculator, but sometimes, depending on what they're asking of you, it might be faster just to look. Range is just the max minus the min. I don't really feel like plugging all of those into the calculator, but if I just take a minute and find that the lowest value is 67 and the highest value is 74, 74 minus 67 is going to give me 7, right? Because that's what the range is the max minus the min. So it's probably faster to just do this by hand than to plug it into the calculator. But if you did want to plug it into the calculator, you'd plug all of these numbers in, right? You go to stat, edit, you'd plug all the numbers into, you know what, you could plug them into list 3 if you wanted to. Like, hey, I'm going to plug a bunch of numbers into list 3. Just random numbers. And then I want it to, I can either tell it to sort. I'm going to do list 3, and it says done, and I can go look at it, and then I can easily see what's my min, what's my max, or I can have it calculate, and it's going to give me my min here, and then I arrow down and it will tell me my max. So those are the two places you can find it if you do it in the calculator, if it ends up being faster that way. Or you could just, like I said, do it by hand. Okay, so here we get into the other types of questions. Find the sample standard deviation, round to the nearest tenth. Sample standard deviation. So let's talk about, here, I'm going to pull up the book because it's got a nice little chart here on page 85, which I think is really helpful. All right, so on page 85, it's got this handy dandy little chart that reminds you what all the symbols mean, okay? So this symbol is the lowercase sigma, okay? This symbol is lowercase mu, like mu, pronounced mew, like a cat, mew. Remember, this is pronounced X bar. And these are the symbols for the sample versus the population. Okay, so you want to make sure that you're familiar with these and that you don't accidentally use sample when you mean population or the other way around. Okay, so for this problem, they want the standard deviation. You can definitely calculate it by hand using the formula, but from what I understand, the professors just want you to know how to do it in the calculator. They want you to know that that there is a formula, but they don't need you to prove that you can do the formula by hand. So we're going to put these now. I'm just going to put it in L4. And we're going to calculate stat calc 1var stats. I'm in L4 at this point. Okay, so the sample standard deviation. So you'll notice that the calculator has the sigma, but it also has an S, right? Because the calculator doesn't know if this is the entire population or if this is just a sample. You have to tell it, or you have to interpret what it can provide to you. It doesn't know if you've provided it with a sample or with a population. So they asked for sample standard deviation. So we're going to look at the S value rather than the sigma value, right? Sorry, S value rather than sigma value. So round to the nearest tenth, so 4.75 rounded to the nearest tenth is 4.8. Sorry, when I'm holding the pencil here, from my perspective, it looks like I'm doing this one. Anyway, so make sure that you're familiar with the sample versus the population symbols, because you don't want to choose the wrong one on the calculator. Okay. We're getting there. Mean length of a human pregnancy is 270 days, with a standard deviation of 11 days. Use the empirical rule to determine the percentage of women whose pregnancies are between 259 and 281 days. Assume the data set has a bell-shaped distribution. So real quick, let's talk about the empirical rule. So also called the 68, 95, 99.7 rule. All right, so in the middle, we have the mean. Then we can say the mean plus 1 standard deviation to the right, or we can say the mean minus 1 standard deviation to the left, or we could go 2 out, or we could go 3 out, right? Mean plus 2 standard deviations. This is the mean plus 3 standard deviations. Okay, so the empirical rule says that if we go out 1 standard deviation to the right and to the left of the mean, that 68% of the data lies right in here. And if we go out 2 standard deviations, that's 95% of the data, or percent of the values. And if we go out 3, we have 99.7%. Okay. All right, so let's take a look at the actual numbers that we're dealing with here. So they said, assume the data set has a bell-shaped distribution. So this is a kind of bell-shaped. I'm trying to make it look bell-shaped. All right, it told us the mean length is 270 days. Mean is 270. So that is right there in the center, right? With a standard deviation of 11 days. So if I went out 1 standard deviation, so if I did the mean plus 1 standard deviation, that would be 270 plus 11, which is going to give me 281. So this, I'm going to call it an X value, not X bar, but just X, is 281. If I went 1 standard deviation to the left, so if I did the mean minus a standard deviation, so if I'm at the mean of 270 and I go 1 standard deviation to the left, or 270 minus 11, I get an X value of 259. So the mean is 270 days. 259 to 281 days is 1 standard deviation to the left and 1 standard deviation to the right. They want to know the percentage of women whose pregnancies are between those two. So they want this percentage. And the empirical rule says that if we go 1 standard deviation to the right and 1 standard deviation to the left, that contains 68% of the data. So that's why the answer is 68. In future chapters, you guys will learn how to do more with this kind of stuff. Yeah, okay. The following data set approximate the sample standard deviation to the nearest hundredth using the grouped data formulas. So again, we've got to plug things into the calculator, right? We're going to have list 1 and we're going to have list 2. List 1 is your midpoints, right? We've done this several times now. List 2 is the corresponding frequency. So again, how do we find the midpoints? We're going to take the average of these, add them up, divide by 2. So on and so forth. Or how did I get from here to here? I added my class width. I'm going to do the same thing to the midpoints. Okay, we find our midpoints. We put them into the calculator as list 1. We put the corresponding frequencies into list 2. We do stat calc, 1var stats, and then we look at the sample standard deviation, which is going to be the S with in the calculator, it has an X next to it. So that's the sample standard deviation, as opposed to that is the population standard deviation. So in the calculator, we're going to make sure we're looking at the S, not the sigma. And we're going to get that. I'm not going to plug it in just for the purposes of time. We're already half an hour over. Okay. The ages in years of a random sample of shoppers at a gaming store are shown. Determine the range, mean, variance, and standard deviation of the sample data set. Okay, so range, easy enough, max minus min. Okay, so that's 23 minus 12. So that's how we get 11. Okay, the mean. Again, we're going to plug all of these into the calculator. So I'm just going to go ahead and do it here. There's not that many. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so we're going to stat, calc, 1var stats. I put my stuff in list 1 and calculate. Okay, the mean. So this is a sample. It's a sample of shoppers. So we need to keep that in mind. Okay, mean is 17.2. Okay, the standard deviation, we're going to jump to that one. That's 3.4 rounded to the nearest 10th, okay? But they also want the variance. So remember that the variance is the square of the standard deviation. That's what the variance is, okay? So I need to take this variance of 3.39280284 and I need to square it. I don't want to round before I square. I want to round afterwards. So I'm going to actually write this down, 3.392800284, and that's what I'm going to plug into the calculator to square. So you can either hit clear or quit, and 3.392800284 square. And then on my calculator, the square, let me zoom out here. The square button is this one right here, x squared. Or you could have also said, you could have done the caret symbol to the, and then hit the 2, the second power. Once we have that number, now we can round. We can round to 11.5. Okay. Radio station claims that the amount of advertising per hour of broadcast time has an average of 12 minutes. Right, so let's go ahead and say average of 12 minutes, and a standard deviation of 2.8 minutes. You listen to the radio station for an hour at a randomly selected time and carefully observe that the amount of advertising time is equal to 18 minutes. They just gave us a data value, 18 minutes. Calculate the z-score for this amount of advertising time. So remember, the formula for the z-score is your x value minus your mean over your standard deviation. Right? That's if you have population. If you're dealing with sample data, it's your x value minus your mean over your standard deviation. Okay, so we're going to go ahead and take our numbers and plug them in, right? Z equals our data value, right? The data value is the x, minus the mean divided by the standard deviation. If you plug that into the calculator, you're going to get 2.14. Again, remember your order of operations, either put it in parentheses or make sure that you hit enter after you do your subtraction before you do the divide. Okay. The weights in pounds of 30 preschool children are listed below. Find the 5-number summary. Okay, the 5-number summary. So let's talk about that. If you have all your data and you divide it into 4 sections, and each section contains 1/4 of the data, the numbers that separate them are your quartiles. So the number that separates the bottom 25% from the top 75% is your first quartile. The number that separates the bottom 75 from the top 25 is your third quartile. The number that separates the bottom 50% from the top 50% of the numbers is your second quartile, which we talked about this before, is also your median, right? And then you have the number over here is your minimum, and the number over here is your maximum. So these values are your 5-number summary, okay? So again, depending on how many numbers you have, it might be easier for you to, and also depending if they've already sorted them, might be easier for you to do it by hand, or it might be easier for you to plug it into the calculator. So let's see, is this in order? It looks like it is in order. But yeah, either way you do it. So it can be easiest to find the median first. Remember, that's your second quartile. Remember, we talked before about if I have an even number of things. So if I have 4 things to find the median, I take it, I divide it in 2, and then I take the average of that number and the one above it to get the median. If I have an odd number, I cut that in half, and then I go up to the next number, and the number in that position, that's the number I use. But yeah, again, your calculator is just it's gonna give all of those numbers to you. Stat calc. I mean, these aren't these numbers, but that's what all this down here is, right? Minimum, first quartile, median, third quartile, max. Just spits them all out for you. Okay, I promise we really are almost done. In fact, is this the last one? This is the second to last problem. Okay. The ages of the winners of a cycling tournament are approximately bell-shaped. The mean age is 28.5 years with a standard deviation of 3.3 years. The winner in one recent year was 36 years old. Transform the age to a z-score. Okay, so let's go through. Let's label what we've got. Okay, mean age is 28.5. Standard deviation is 3.3, and then it's giving us this data point, this X value, which is 36. Okay, transform that to a z-score. So we're going to use our formula. X minus the mean over the standard deviation. Okay, so that's going to give us this 2.27 when we plug it into the calculator. Okay, then it wants us to interpret the results. So let's kind of draw what we're looking at here. So the mean age is 28.5 is the mean. So a standard deviation of 3.3. So 1, 2, 3, 1, 2, 3. So each of these is going to represent one standard deviation. The age of this winner was 2.27 standard deviations. So that, first of all, that's positive. So we're going to the right. So they went 1, 2, and then a little bit more, maybe like a quarter more. They were over here, right? This is where 36 is. The X value of 36 has a corresponding z-score of 2.27. Because remember what the z-score means. The z-score means how many standard deviations from the mean are you? You are 2.27 standard deviations to the right of the mean. To the right because it's positive. If it had been negative, it would have been over here. Standard deviations to the right of or above the mean. Okay, then they want to know, is this unusual? So usual versus unusual. So you have the mean right here, and then you have, if you go 2 standard deviations in each direction, everything inside of that is usual. It's fine, it's normal. But if you go more than that or less than that, it is unusual. Okay. So my fiance always jokes about how I am short, but I am not short. I am 5'5", which is within 2 standard deviations for someone of my age and gender, which means it is not unusual, it is usual. Okay, so there's a real world example for you. But in this example, this value is unusual because it is outside that -2 to 2. I mean, it's just outside of it, but it is. It's beyond 2 standard deviations. It's 2.27 standard deviations. Okay. All right. And finally, the last one. Table shows population statistics for the ages of Best Actor and Best Supporting Actor winners at an award ceremony. The distributions of the ages are approximately bell-shaped. Compare the z-scores for the actors in the following situation. So we've got Best Actor, average age is 41, and a standard deviation of 9.2. Best Supporting Actor, the average age is older, right? It's 55, and the standard deviation is more, right? It's got more spread. It's 12 rather than 9.2. So Best Supporting Actor, we've got a wider range or a wider spread of winners. Okay, in a particular year, the Best Actor was 40 years old, and the Best Supporting Actor was 82. They want us to find the corresponding z-scores for each, so we're going to use the formulas. So for Best Actor, we have X minus the mean over the standard deviation. Now, when you plug this in, you are getting a negative number, right? You are getting negative 0.11 because the age of the Best Actor is to the left of the mean. That's why it's negative, right? If we were to draw that, we have a mean of 41. This data value of 40 is to the left. I mean, it's not far from the left, but it is to the left. In fact, it's negative 0.11 standard deviations to the left of the mean. Okay, and then for the Best Supporting Actor, we have X minus the mean over the standard deviation, and that's going to give us this 2.25. So again, if we kind of look at what we have here, we have a mean. We have a mean here of 55, and then we go 1, 2 1/4 out. I mean, this is not to scale. This is just, I can only fit so much. We have this 82-year-old winner. Imagine that, still working at 82, or still enjoying your job at 82. I should say it that way. So that is a whole 2.25 standard deviations to the right of the mean, right? Because they're much older than the average, than the mean age for the group, whereas this person was younger than the average winner, right? So, okay, interpret the z-scores. Okay, well, we kind of just did that, right? The best actor was less than 1 standard deviation below, not even a full standard deviation below the mean. That's not unusual. But I'm sorry, that was best actor. The best supporting actor was more than 2 standard deviations above the mean, which is, that's on the next page. I really need to take that page out. That is unusual, because remember, if we are within 2 standard deviations, that's a 2, it's usual. If we are beyond in either direction, that is unusual. Okay. Okay, and with that, we have circled around to the beginning. So again, I just want to remind you guys, do not hesitate. Oh, you can't see that, the reflection. Don't hesitate to reach out to your instructors for assistance. Don't hesitate to reach out to any of the academic support centers. We have an ASC on every campus except for the ATC. We also offer virtual chat in the evenings until 7:30. So if you can't physically come in, and then also on Saturdays, the Academic Support Center at the Daytona Building 115 is open from 8 to 4. So you can get help on Saturdays too. I will, if you provided me with your email address, either in the chat or by emailing it to me here, I will email you a link to this so that you can review it in your own time when it's more convenient. And I will also just provide a link to the Academic Support Center so you can look up our hours and when we are open. I hope this was helpful. If you have any specific questions, feel free to ask them. But otherwise, we're going to wrap it up here. I'll give you guys a minute to provide either your email or to type in a question if you did have them. So what I'll do is so the link is the same every time. So wherever you found it today, just go back to that same place. I will include the link to the review as well as to the recorded review. They're 2 different links, right? So that you can just have that in your email. I provided that link to the math department, and they disseminate that out through the professors if the instructor does want to provide that. Some instructors are kind of protective of their students, and they have a particular way that they want to do things, and so they may not want the students seeing potentially other ways of being done. So, certain instructors may have chosen not to provide the link, and that's fine. But yeah, I can definitely email it out. So. All right, Alexis, I'll give you a minute to finish typing. Oh, gotcha. Okay. Yeah, that happens too. They've got a lot going on, to be honest, and uh, you know, it's kind of just one more thing on their to-do list. So they may forget as well. But yeah, you can always find the links on the Academic Support Center's website, as well as I will email it to you. All right. Well, good luck, everybody. And I hope you guys do well. Thanks for coming. Um, and I'll see you next time. Sorry, I'm gonna, oh, gotcha. All right. You're welcome, Alexis. All right. Take care. Bye.